Today I'm presenting some findings from recent glider programs undertaken by JASCO Applied Sciences and collaborators offshore Nova Scotia, Canada. The first program was undertaken in Roseway Basin using a fleet of 3 gliders called Glider, Decibel, and Harmony. Each glider had an array of 4 hydrophones to allow for directional analysis of acoustic data. Today I'm summarizing the different types of information that can be gained using a fleet of gliders with hydrophone arrays. First, these programs can send detections to shore for an analyst to review in near real time to allow for informed mitigation decisions. This is an example of the detections that came to shore from Roseway Basin where in real time, fin, sei, and right whales were detected. This is the same raw data once the gliders were retrieved. You can see how the real-time detections aim to send as much information to shore as possible to mimic a spectrogram and allow analysts to make decisions based on all available context. With the hydrophone array, the spectrograms can be converted to directograms, where color indicates the estimated bearing defined by the color wheel legend, where up is north. Directional data opens the analysis up to a new level of information. For example, with this directional information, we can calculate the minimum number of animals present. Here we have a right whale upcalling from the northeast and another upcalling from the southeast, with a sei whale downsweep from the southwest and 1 to 2 fin whales singing. There's also a purr in green from the northwest that may indicate a humpback whale. In this example, we can count the minimum number of right whales producing gunshots. This example has at least 4 calling animals, shown in pink, blue, red, and yellow. We can really see how we can jump from we have right whales present to we have at least 4 right whales present. You can take this a step further and track individual whales. This can give a better idea of what species is producing which sounds. In this example, there are lots of gunshots, but also lots of moans that often fall into the category of is this a humpback or a right whale? On these unknown moans from the southwest, we see they are also associated with right whale gunshots. I can then zoom out for more context and see that these moans and gunshots are tracking together through time, adding more evidence that the moans are indeed part of the right whale repertoire. Here's another example where we can look at questions like what is the call rate of a single whale, or how often does a whale switch between gunshots and upcalls? Here's an example of bouts of an animal switching between the 2 call types over several minutes, being tracked as it moves relative to the glider. When the same animal or group of animals are recorded on multiple gliders at the same time, the specific location can be estimated. In this example, we have 2 upcalls on all 3 gliders. We can look at the glider location and the bearing to estimate the animal's location. Noting that for the farthest glider, the calls were too faint to get a good estimate on bearing. Notably, the farthest glider recorded the faint upcalls approximately 30 kilometers from the animal's location. In summary, the fleet of directional gliders brought back a wealth of data to be investigated to inform mitigations, estimate animal density, movements, repertoire, and explore topics like detection range and source levels. To end this talk, I want to highlight a very noteworthy finding from a glider JASCO deployed off the Scotian shelf earlier in spring of this year. The glider moved off the shelf edge, and at its very farthest point before having to return, we had a confirmed North Atlantic right whale detection. This discovery in more than 3,000 meters of water at 120 kilometers from the shelf edge warrants further monitoring in these offshore regions. Thank you for your attention and to the large group of people that contributed to this work. I'm happy to receive any questions via email.